I'm Dr. Aditya Prasad. Today I'm going to discuss about Alpha principle, Pauli's exclusion principle, Hund's rule. Okay, simply all these rules together I can say A, P, H. A for above principle, P for Pauli's exclusion principle, H for Hund's rule. How we can, for what purpose we need to study all this? If we want to fill the electrons in an orbital, we need to know all these three rules. Without obeying these three rules, we should not fill the electrons in the orbitals. What are the electrons and what are the orbitals? For example, if you take an example of nitrogen. To the nitrogen, we need to fill the electrons in the orbitals. How can we fill that? For example, let us consider 1s orbital, a 2s, 2p, what is the atomic number of nitrogen? Atomic number of nitrogen is a 7. In this, what we need to do, 7 electrons we need to fill in a lower energy level to the higher energy level. Consider 1s is a lower energy, 2s is the next higher energy, 2p is another next higher energy. Here, how can we fill these 7 electrons? That filling of the electrons in the orbitals will be explained by these three rules. First one is a above principle. What is above principle? Orbitals of lowest energy filled up first. What is the lowest energy? Lowest energy is 1s and then 2s and then a 2p. Here lowest energy level should be a fill. For example, if I fill like this, one here, one here, one here, one here. Like this if I fill. Total 4, 5, 6, 7. Total 7 electrons if I fill this. Is this correct? No. This is wrong. Why it is not why it is wrong? Why? Because it never obeys the above principle. What is above principle? Orbitals of lowest energy should be filled first. Here it has not completely filled. Without filling this, here 2s energy level filled. Next 2p energy level filled. So this will not obey the above principle. Next one is Pauli's exclusion principle. Let us have a same example for these also. 1s, 2s, a 2p, here total 7 electrons here. Total 7 electrons we need to fill. What is the condition? No electrons in an atom have the same quantum number. Quantum number is means what? One should be up and one should be down. For example, if I fill like this, is this obey this rule? No. Why it will not obey this rule? Why? Because here this is having a both same spin electrons in an orbital. It should not be like this. So these type of things it never obeys. What it said? It is excluding to fill the same spin electrons in an orbital. So we should not do like this. Next, Hund's rule. What is Hund's rule? Multiple orbitals of same energy should be one in each before they develop. Take the same example, nitrogen example. Here also nitrogen atomic number is 7. So we need to fill the 7 electrons. Here, for example, if I fill like this, 4, 5, 6, 7. I am filling like this. Here, this thing can be obeyed by above principle and Pauli's exclusion principle. These two rules can be obeyed. But what about Hund's rule? These can be obeyed by the Hund's rule? No. Why it will not obey? Why? Because what we said, multiple orbitals in the same energy. Here this is a multiple orbital having the same energy. 2p orbitals there are 3 orbitals in the p, so it is having the same energy. Multiple orbitals of same energy should be 1 in each before they double up. It should be each column should be filled 1 first, then only it should be get doubled. So here we have not done like this, so it will not obey the Hund's rule. Okay. For example, if you consider, if you are traveling in a bus, first which seat will be preferring? First we will prefer the window seat, then only we will prefer the second seat. Likewise here, all the electrons must be taking the window seat. Afterwards only they will be preferring the second seat. Okay. So how can we do? By following all the 3 rules, by obeying all the 3 rules, how can we satisfy all the 3 rules? 4, 5, 6, 7. Oh. If you write like this, all the 3 rules can be obeyed. Okay, yes, this will be obeying all the 3 rules. What says the first rule? Lowest energy level should be filled first. Here, lowest energy level is filled, then only it is going up. Next, Pauli's exclusion principle says, no same quantum number should not be filled in a same orbital. Here, one is plus half and one other is negative half. Each one has been satisfied here. Next, Hund rule says, in the last final same orbital should be 1 electron should be filled first, then it will get a double up. If I will do like this, 1 electron it will get filled up here, it will not accept the Hund's rule. First it should be filled each orbital, then only it should get a double up. If you follow all this, we can able to satisfy the thing.